everyone, and welcome. I'm Helio Pereira, Head of Business Development at Bixtech. For more than 15 years, I've worked across consulting, business intelligence, automation, and AI initiatives. Now, over the past few years, one thing has become very clear. The conversation about artificial intelligence is finally maturing. Not long ago, most discussions about AI were speculative. Would AI replace developers? Would machines eliminate entire professions? Would software engineering even exist in 10 years? These questions dominated headlines for a while, but in 26, they feel outdated. The real shift is no longer about whether AI can generate code, write documents, or analyze data. We already know it can do these things. The real question now is what happens when AI stops being an experiment and it starts becoming part of the infrastructure that companies rely on every day. When AI begins influencing pricing models, logistics operations, financial forecasting, and software architecture, it stops being a novelty. It becomes operational infrastructure. And infrastructure changes how organizations think about responsibility, reliability, and governance. The scale of adoption helps explain why this transition is happening so quickly. According to McKinsey's 24 Global AI Survey, about 65% of organizations reported using generative AI at least in one business function, almost double the rate from the previous year. At the same time, IDC estimates that global spending on AI will reach around $500 billion by 27. Most of that investment is not going to experiments or prototypes. It's going to integrating AI into operational systems that companies depend on every day. Looking at how large technology companies are approaching this transformation helps illustrate what is happening beneath the surface. Meta, for example, has taken a very aggressive approach to building an open AI ecosystem. Their Llama models have become some of the most widely adopted open weight models available today. According to Meta's developers updates, Llama models surpassed 100 million downloads across the ecosystem in 24. That number is significant because it signals something important about the future of AI infrastructure. Many companies are reluctant to send sensitive operational data to external providers. Financial information, proprietary data pipelines, internal operational metrics, these assets are central to how organizations compete. By releasing powerful models that companies can run inside their own infrastructure, Meta is accelerating a model where organizations operate AI internally rather than relying entirely on external platforms. In other words, intelligence becomes something companies run, not just something they purchase as a service. Once that shift happens, AI becomes part of the architecture of the company itself. Apple is approaching the same transformation from a different direction. Instead of focusing primarily on massive centralized models in the cloud, Apple has been investing heavily in on-device AI. The neural engine in the latest Apple silicon chips can provide up to 38 trillion operations per second, according to Apple's technical documentation. That capability allows complex machine learning workloads to run directly on personal devices. Running AI locally changes two important variables at the same time. First, latency. Systems that run locally can respond instantly because they do not depend on network calls to remote servers. Second, privacy. When the model runs on the device, sensitive information does not need to leave the user's environment. For industries operating under strict regulatory requirements, such as healthcare or finance, this architectural decision is extremely important. It allows AI to integrate into workflows without exposing confidential data. Another critical dimension of the AI conversation is governance. Companies like Anthropic have focused heavily on building systems that are not only powerful but predictable. Their Claude models are built around an approach known as constitutional AI, where models are trained to evaluate the responses against a set of defined behavioral principles. This matters because once AI systems influence real operational decisions, those systems need guardrails. The Stanford AI Index reports that AI systems are now being developed across sectors ranging from medical diagnostics to financial risk modeling. As AI begins affecting real-world outcomes, reliability and transparency becomes as important as performance. These changes are also transforming how software is built. One of the most visible shifts inside engineering teams today is the rise of AI-assisted development. Tools powered by large language models can now generate substantial portions of working software. GitHub reported that developers using Copilot completed coding tasks up to 55% faster than developers working without AI assistance. That level of acceleration changes the role of developers themselves. Instead of writing every line of code manually, developers increasingly define the architecture and the intent of a system, while AI generates much of the implementation. But speed does not automatically guarantee quality. Many engineering teams are already encountering a phenomenon sometimes described as code erosion. AI-generated code often compiles and passes tests, but over time, subtle inconsistencies begin to accumulate. Architectural patterns drift, redundant logic appears, systems slowly become harder to maintain. The system still works, but maintaining it becomes more complex over time. This means the role of engineers evolve again. Developers are no longer just writing code, they are responsible for protecting the integrity and coherence of systems that increasingly include machine-generating components. Another emerging trend is the use of multi-agent systems. Instead of relying on a single model to complete a task, organizations are beginning to design workflows where several AI systems collaborate. One system may generate code, another evaluates the output, another runs tests, and another monitors performance after deployment. This architecture mirrors how human teams already operate, with different agents specializing in different responsibilities. One design principle is becoming increasingly important in these systems: uncertainty detection. Responsible AI systems should not simply generate confident answers. They should recognize when a problem exceeds their confidence threshold and escalate the decision to a human. This ability to detect uncertainty may end up being one of the most important characteristics of reliable AI systems. The goal is not full autonomy. The goal is a dependable collaboration between human judgment and machine scale. As AI continues to evolve, the organizations that succeed will not necessarily be the ones with the most powerful models. They will be the ones that understand where intelligence creates real leverage, where prediction improves decision-making, where automation accelerates operations, and where human oversight remains essential. Despite the rapid technological progress we're seeing, the most effective AI systems today are not autonomous. They are collaborative. Machines process scale, humans provide judgment, machines identify patterns, humans define strategy, machines accelerate execution, humans decide direction. The partnership between human expertise and machine intelligence is what will ultimately define the next generation of real AI applications. Thank you for listening, and I'll see you in our next episode. Bye.